Well, good evening, grade 8s. Amazing that you tuned in here for your final review before your test tomorrow. We're going to start just with some warm-up questions, and the first question says P bracket 4, comma 1. And for those of you who are struggling a little bit, what this says is, what is the probability? That's what the P stands for. It's a probability. That P means what is the probability of a 4 on the first spinner and a 1 on the second spinner. So if I have to interpret what this thing says here, what it really says is, what is the probability of a 4 on the first spinner and a 1 on the second spinner? So by grade 8, in grade 7, you learned how to take it as a table or as a tree diagram. You learned to make it like this. You learned to see by looking at this area right in here and count them that there were 16 possible combinations. Of those 16 possible combinations, if this was the first spin and this was the second spin, a 4 on the first spin and a 1 on the second spin would be this square right here, which would be a 1 out of 16 chance. And then you could convert that to a decimal and a percentage by taking your calculator. What is 1 divided by 16? It is 0.0625, which as a percent is 6.25%, or approximately just 6% chance if you wanted to round it. So in grade 7, you learned how to do that. In grade 8, you learned that if you took the probability of favorable outcomes, divided by possible outcomes, which was also learned in grade 7, you have 4 possible outcomes on that first spinner, one of which is the number 4. On the second spinner, you have, again, 4 possible outcomes, one of which is the number 1. If you were to multiply those two together, you would get 1 chance out of 16, or that is a decimal, that is a percent, that is an approximate percent. So without having to do this physical table of values, you're able to get the answer by just multiplying individual event probabilities, right? So if you can't multiply, if you thought it was 1 out of 8, then what you really struggle with is not the probability side of it, it's how do you multiply fractions. Remember, when we multiply fractions, we multiply the numerators and we multiply the denominators, and we get 1 out of 16. Some people are still stuck that they add the denominators, which is wrong, right? You have to multiply the denominators together. Okay, so your answer for that practice question is 1 to 16. All right, the second question. Press pause, try this question, and see, and then you could press unpause and see how well you did. All right, so here's the solution to the question. If I'm doing this in a grade 8 level, the probability of a 1 on the first spinner and a 1 on the second spinner. Well, on this first spinner, the probability of a 1 is 1 chance out of 4. And a probability of 1 on the second spinner is 1 chance out of 3. So the product of those two is 1 out of 12. Be careful that you don't have 1 out of 7, because 4 times 3 is not 7, it's 12. Which as a decimal, if I take my calculator, equals 0.083 repeating, which is approximately 8.3%, or approximately 8% if you round to the nearest whole number, both of which are correct. All right, press pause here, see how well you do. Okay, so the first one says, what's the probability of a heads on the first event and a 1 on the second event? Well, the probability of a heads is 1 chance out of 2. The probability of a 1 is 1 chance out of 3. The product of those two would be a 1 chance out of 6 if that happens. Okay, that's the answer for that. And if you wanted to, you could actually physically make, your table, heads and tails, 1, 2, and 3, and you could physically see that there's 6 possible combinations, and only one of them, this one right here, is a heads and a 1. So 1 chance out of 6. And as a percentage, as a decimal, 1 divided by 6 gives me 0.1666 or 1.6 repeating, or approximately 16.6 repeating percent. Actually, that's equal to, or approximately 16.7%, or if you wanted to, approximately, if you want to round to the nearest whole number, 17%. Try this one. Press pause and I'll show you the answer. Okay, for this one, it's a 3 event, right? So if I was to actually try and model this, I would have had to have used a tree diagram, and it would have looked something like this, heads and tails. It would look like 1, 2, 3, 4, and then 1, 2, 3, 4, and then it would have been 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And the same thing down here. Okay, but I won't do it. So there would have been 4, 8, there would have been 16 up here, and there would have been 16 down here, and there would have been only one pathway, this one right here, that would have been a heads on the first, a 1 on the second, and a 1 on the third. There would have been 1 out of the 32 combinations. I'm sorry, 4, 8, yeah, 16. So let's look at how that translates into grade 8. So you have a 1 chance out of 2 of getting heads. You have a 1 chance out of 4 of getting. I did do this. No, I didn't do it. And you have a 1 chance out of 4 over here getting it. So if you multiply this out, you get 1 times 1 times 1, which is not 3, and 2 times 4 times 4, which is not 10. It's 1 out of 32, which is, as a fraction, the probability that it'll happen. It'll happen 1 every 32 times you do something, theoretically, right? And if we change this to a decimal, it would be 0.03125, which is 3.125%, or approximately just a 3% probability of that happening. Depending which, this is the better answer, but probably for a lot of the questions, if you said it's around 3% chance of happening, that's a pretty good answer. All right, try this one. Okay, for this one, you have 3 events again. This time it's a little bit more complicated. It's the probability of getting an even on the first spinner, an odd on the second spinner, and just a 1 on the third. So an even number, there are 2 out of 4 for that one. There are 2 out of 4 odd numbers. There are odd numbers there and even numbers here. And you get a 1 chance out of 4. So if I'm going to multiply those out, I'm going to get 4. Because 2 times 2 times 1 is 4. 4 times 4 times 4 is 64. So you're getting a 4 to 64 chance, or in lowest terms, a 1 out of 16 chance, right? And if I was to take 4 to 64 and change it to 4 divided by 64, we just saw that in the last question, it's 0.0625, which is approximately, which is equal to 6.25%, or approximately equal to a roughly 6% probability that that happens. The next question says, what's the probability, the probability of it raining in Summerside is 40%. The probability of it raining in Charlottetown is 60%. What is the probability of it raining? Let's change these up a bit. Let's just go, I'm going to change 60%. I'm going to change this to, let's change this here. I'm going to go backspace this up. Backspace, backspace. Let's go 60% here. And here we're going to go 80%. Okay, we're going to change it just a little bit, make it a little bit more complicated. So what's the probability of it raining in both cities at the same time? So there's 3 ways to think of it. So we know that 60% in Summerside, and we know it's 80% in Charlottetown. So it's a pretty good chance it's going to rain in both cities, right? We can think of 60% as being 60 hundredths or 80 hundredths. We can think of it as being 60 out of 100 as a fraction. 80 out of 100. Or in lowest terms, not in lowest terms, but in just reduced terms, the easier one is 6 out of 10 and 8 out of 10. All of these are the same thing. So since we're talking about combined probability, what we want to do is we want to think about the product of the 2 individual events happening. And if we look at these, This one and this one are the best ones to do because this one doesn't make sense. You're like, I don't know how to multiply percentages together. According to this, I get 140%. So since we've never really talked about multiplying percentages in percentage form, this one makes sense and this one makes sense. And this one does make sense, but when we multiply those numerators and multiply the denominators, we actually get this 4,800 out of 10,000, which is pretty hard to see as a percentage. But over here, we get 48 out of 100. So therefore, since it's a 60% chance of raining in Summerside and an 80% chance of raining in Charlottetown, the combined probability will be 48%. Come in. 48%. But the interesting thing is this would have worked as well if I had to change the percentages to decimals, which we don't do in the book, but if we did, a 60% chance times an 80% chance gives us a 48% chance still. And a lot of people think that this would have been a 1.4 or 140% chance, but that would be if you added them together instead of multiplying them, right? So we have to be careful that with combined probabilities, it's the product. So 60% of 80% is only 48%. All right, try this one. Press pause and see how well you do. Okay, so for odd, we have a 2 chances out of 4. For heads, we have a 1 chance out of 2, and for tails, we have a 1 chance out of 2. The combined probability of that event happening is 2 out of 16, or 1 out of 8. And 1 out of 8 is one of those easy ones because if you multiply by 125 and multiply by 125, you get 125 over 1,000, which is 12.5 out of 100, which is 12.5%. Now, if you didn't know that, you simply took this one, which was the product of all three of them. You took your calculator and said, I don't know what to do here. I'm just going to go 2 divided by 16. It equals 0.125, which is actually this number right here. And then you could have taken this pathway here to get to there, or you could have just said, there's my percentage. So it's 12% plus an extra 0.5%. Another way you could have done it is you could have reduced this one to lowest terms to start. You could have said 1 over 2 is the same thing. I got a 1 chance out of 2 of hitting an odd number and reduced it prior to product. And you would have gotten 1 out of 8, which is right here, and you would have got the same answer. So either way you do it, the probability of getting an odd heads and tails is roughly 12.5% chance, or 13% if you want to round. Here's another question. What's the probability of a 1, 2, 3, 4 on 4 different spinners? Okay, so the probability of a 1 on each of these is going to be 1 out of 4 chance for the number coming up on that. The product of all 4 of these different events, 1 times 1 times 1 times 1, and 4 times 4 times 4 times 4, will be 1 in your numerator. Now 4 times 4 times 4 times 4 is something that probably most of us can't do in our head easily. So I can go 4 times 4 times 4 times 4, and then press the equals button, and it gives me 256. So the probability of that happening is 1 out of 256. Another interesting way to think about it is 1 to the power of 4 and 4 to the power of 4. But that idea is really a grade 9 outcome, so if you don't understand it, don't worry about it. But no matter what you do, the probability of me going a 1, 2, 3, 4 on those spinners is a 1 chance out of 256, which as a percentage, 1 divided by 256 is 0.0039. Since there's my hundredth, it's 0% and 39 hundredths of a percent, or roughly 0.4%. Okay. How many postal codes are possible based on this one? Letter, number, letter, number. So this is a postal code that is used in Canada. We have 3 letters and 3 numbers. How many different combinations are there available for postal codes? Well, if we look at the first number, C, there are 26 different letters you can use, right? In number, there are 10 different numbers you can use, including 0. For this next letter, you have 26. For the next number, you have 10. For the next number, you have 26. And for the last letter, you have 10. So if you think about it, this is letter, number, letter, number, letter, number. It's not asking you for any specific postal code. It just wants you to say how many possible combinations are there. So if I take my calculator, bring it up here, and go 26 times 10 times 26 times 10 times 26 times 10, and press equals, I get 1757600, or approximately 17 million. I don't need the one up there. So there are 17,576,000 different combinations of postal codes, which means if you broke down the entire country into 17 million different regions, each one with its own unique postal code, that would allow us to have unique postal codes for everywhere in Canada. That's kind of an interesting one when you think about it. All right, the next one. You can't really see this very well, can you? Let's maximize it. It says, what is the probability of a blue blue? So for this one, you have bag 1 and bag 2. And it wants to know, what is the probability of drawing out a blue chip from that first bag? Well, this one's blue, this one's blue, this one's blue, and there are no other blues. So there are 3 blues out of a total bag of 10. So really, the probability of pulling out a blue chip from that first bag is 30%. And the probability of the second bag, there's a blue, 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 blue. There are 8 chances out of 10 in the second bag. Right? So the theoretical probability of both events happening would be 24 out of 100, or exactly 24% probability. Okay, so the probability of blue blue in this particular question would be 24%. And try this one. It says draw a table that shows the probability of rolling doubles with 2 dice. So if I was to say doubles, what's the table? So a dice has 6 numbers, so I'm going to put 1, 2, 3, 4. Well, a standard dice has. You could interpret it as being a different dice, but that would be weird. So this would be a table that shows all the different possible combinations. And all the ones that are doubles would be ones like this. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So out of the 36 possible combinations that are there, 6 of them are doubles. So for this one, you could say there's 6 out of 36, or in lowest terms, 1 out of 6, or as a percentage, roughly 16.6%, or approximately 17%. Or you could have also said 16.7%, because you could have rounded this one up to a decimal sign. Okay. Hopefully these review questions help you. If you have any more questions, leave a comment in the comment box, and if I can provide you additional support tonight. And hopefully tomorrow you do very well on your test.